In this video, I'll go through a couple of examples. We'll predict the products for all of the examples, and for this first one, we'll draw the mechanism as well. So we have an alcohol that we're starting with, and then you see we have sodium hydride. So we have a strong base and an alkyl halide. So this is the first type. This is the Williamson ether synthesis. If all we're doing is predicting the product, we know that for the alcohol, we keep the alkyl chain and the oxygen. So in the product, we'll have the cyclopentane chain and the oxygen. And then that oxygen is bonded to the carbons that are part of the alkyl halide. If we count carbons here, we have 3 carbons. So there should be 3 carbons bonded to that oxygen. And this is the final product of the synthesis. The byproducts are sodium bromide, because our alkyl halide is an alkyl bromide, and hydrogen gas. Now, if we're asked to draw the mechanism, we can certainly do that. So let's do mechanism down here. We have the alcohol in the presence of a strong base. So that means that the alcohol is going to act as the acid and donate a hydrogen. The hydride ion takes the acidic hydrogen. Oxygen gets the non-bonding electrons. So we have our alkoxide. We have H2 as a byproduct, and then now we use the alkyl bromide. We have a polar bond between the carbon bonded to bromine and the bromine, where the bromine is pulling electron density. That makes this carbon that's bonded to bromine electropositive or electron deficient or an electrophile. All of those words properly describe that carbon. Then we have a electron dense oxygen. And so that oxygen creates a bond to the carbon, and the carbon to bromine bond breaks. And then we get our final product, where this oxygen, one of the lone pairs, is now bonded to that carbon. There were 3 carbons there, so we have 2 more to draw, 3 total. We now have neutral oxygen, 2 lone pairs and 2 bonds. And we have our sodium cation and bromine anion. I did forget to draw the sodium cation in that second step, so I just added that there near the oxygen. And that's the mechanism for that ether synthesis. So proton transfer and then substitution reaction. So here's example 1. Let's do another example. For this one, let's just predict products here. So we have tert-butyl alcohol right here. We also have ethanol. So 2 different alcohols are present. We have a strong acid. So in this case, the reaction goes through that alcohol dehydration mechanism, where we connect the R groups of 2 alcohols and we keep one of the oxygens to create that ether. So to predict the products, we could essentially take the R group from the tert-butyl alcohol and then the R group and the alcohol from the ethanol and create this ether where we have tert-butyl group from tert-butyl alcohol and then the ethanol without the hydrogen as the second part, and that is an ether. There are also different possible products here. We could combine two tert-butyl alcohols. So we have tert-butyl from the tert-butyl alcohol and another tert-butyl group, assuming that we have excess tert-butyl alcohol present. That's another possible product. And we could do the same thing with the ethanol and make diethyl ether, where we take the same R group from ethanol and combine them together. All three are possible products. In this reaction, actually, let's go back to the mechanism for alcohol dehydration. We have remember we formed this good leaving group that's circled in blue here, and that leaves, and we create a new bond with the second alcohol. When we have tert-butyl alcohol, like we do down here, so let's draw just real quick this protonated alcohol. So we have a good leaving group. Now the carbon that's bonded to the good leaving group is a tertiary carbon. So the the water, which is a good leaving group, will readily leave the molecule, and we have a tertiary carbocation here, and that will happen relatively quickly. That's ready to react with ethanol, so that makes this first one that we drew the major product. So that's the major product, and that's because tert-butyl alcohol or tert-butanol will readily form a carbocation. So it gets protonated, it forms a carbocation, then it will react with the ethanol. So although there's three possible products, forming that carbocation on tert-butyl alcohol or tert-butanol will form quickly, and then it will react with the ethanol and form this major product, which is ethyl tert-butyl ether.